Okay, so again, we know how to get between mass and moles, and we know how to get between moles and representative particles. Let's try to go the full distance, see if we can connect the two. Okay, so there's two methods. One method is the way that most people are taught and the way that I was taught, and I don't see anything wrong with it. There's another method that I saw online last year that basically makes it a little bit shorter, using the exact same knowledge that we know from method one. So I'm going to show you both. You use what you like when you're solving problems. Okay, the first method takes into account that you know a couple conversion factors. Okay, you know that 1 mole of anything is Avogadro's number of representative particles. Okay, you also know that 1 mole of anything is equal to the number of grams in molar mass. I was going to say like from molar mass of anything. Okay, so we see that both of these conversion factors have moles in common. So if we know representative particles, we can get to moles, and from moles we can get to grams. If we know grams, we can get to moles. If we know moles, we can get to particles. Okay, so a lot of the times they'll set it up where you've got, let's just go from mass first, and where you just use both conversion factors. So if you know the mass, okay, you can use a conversion factor where you end up with 1 mole on top. And I'm going to go ahead and use this notation. So the number of grams per molar mass on the bottom. That way the grams cancel and you're left in moles. And then they'll go ahead and use this conversion factor here to representative particles. To get into either atoms or formula units or molecules. Okay, so they'll take whatever mass you have, divide by the molar mass, and then multiply by Avogadro's number. Okay, you'll see that your masses will cancel, your moles will cancel, and you're left in number of representative particles. Okay, method 2 uses this kind of setup here. So it takes these exact same conversion factors, but since there's 1 mole in common, they're going to set it up like this and say that Avogadro's number of representative particles is 1 mole of whatever substance you're dealing with, which means that if you've got 1 mole, then it's also the number of grams from the molar mass. Okay, which means that sometimes you can just bypass that mole part, because if they're all equivalent, then Avogadro's number of representative particles should have the same mass as your molar mass. Okay, and I'll draw the similarity here in just a second. So here, if you're starting with mass, okay, you can use these two guys as a conversion factor. So you're going to still divide by the number of grams for molar mass, and go ahead and multiply by Avogadro's number of representative particles. So your grams still cancel, and you're left with number of representative particles. Okay, if you look here, we still divided by molar mass and multiplied by Avogadro's number, just like in method 1. In method 1, you'll notice that you multiply by the number 1 and divide by the number 1, and your moles cancel. So really, this step is not necessary. You can combine the two, and that's what kind of thinking about the relationship between particles, moles, and molar mass is. It kind of makes it a little simpler. Really, it's whatever floats your boat. This is a little less writing. It's the same math, but the same meaning. So kind of take your pick. Now, if you wanted to get from representative particles to moles, you would just have to do the inverse operations. And that's something that I'll just show you when we're working problems.